Hello all, welcome to another quick learning. Today we're going to go back to learning SQL on Codecademy. This is part 3. So if you want to go back to part 1, I'll put a link down in the description and start from there. You can see, so we've done 1, this manipulation exercise. The pro exercises are you have to pay for, so I'm not doing those. And then we did the queries exercise here, and now we're going to be doing the aggregate functions interactive lesson. So let's go ahead and get into it. So we got an introduction. We've learned how to write queries to retrieve information from a database. Now we're going to learn how to perform calculations using SQL. Calculations performed on multiple rows of a table are called aggregates. In this lesson we have given you a table named fake apps, which is made up of fake mobile applications data. Here's a quick preview of some important aggregates that we will cover in the next 5 exercises. So we got count, which counts the number of rows. Sum is the sum of the values in a column. Max and min are the largest or the smallest, respectively. AVG is the average of the values in a column, and round rounds the values in a column. So let's go ahead and get started. And instructions 1, before getting started, take a look at the data in the fake data app. So we're just gonna do select star from fake apps to see what the data looks like. If you remember, star just pulls all the columns from a table. Run that and you can see here we got an ID, a name, a category, the number of downloads, and it looks like the price of those apps. Alright. So count. The fastest way to calculate how many rows are in a table is to use count function. Count is a function that takes the name of a column as an argument and counts the number of non-empty values in that column. So you can see select count star, which means all of the rows from specify a table name. Here we want to count every row, so we pass star as an argument inside the parentheses. Let's count how many apps are in the table. In the code editor, run. So select count star, so we're counting all the rows. Then we're doing fake apps. And we'll end it with the semicolon. And run that. And you can see there's 200 rows in this database table. And then they want you to add a where clause in the previous query to count how many free apps are in the table. All right. So here you can see the schema. So there is a column called price. So we're going to use that. And where it's equal to 0, it's a real number. So you don't need quotation marks. And you can see there are 73 free apps. So sum. SQL makes it easy to add values in a particular column using sum. Sum is a function that takes the name of a column as an argument and returns the sum of all values in that column. What is the total number of downloads for all of the apps combined? So you select sum of downloads. So downloads is just the quantity, it's an integer of the number of downloads. From fake apps, this adds all the values in the downloads column. All right, let's find out the answer. So select sum, and the column we're interested in, downloads. The table we're going to do is fake apps. End it with a semicolon. Run it, and looks like there is about 3.3 million downloads of all the apps in that table. Max and min. The max and min functions return the highest and lowest values in a column respectively. How many downloads does the most popular app have? So you would do select max of downloads from fake apps, and it'll give you the row, the number that has the highest downloads. The most popular app has 31,090 downloads. Max takes the name of a column as an argument and returns the largest value in that column. Here we return the largest value in the downloads column. Min works the same way, but it does the exact opposite. It returns the smallest value. What is the least number of times an app has been downloaded? I'm guessing this is going to be 0, but we'll find out. So we're going to use min, do that from fake apps. Finish it with a semicolon. We'll run that. Ooh, the min is actually 1,387. Delete the previous query. Write a new query that returns the price of the most expensive app. All right, so I'm actually just going to delete this because we're still taking it from the fake apps. And most expensive, so we're looking at max, and we're looking at price, because price has the, as it would, the name would imply, the price. And $14.99 is the most expensive. Average. SQL uses the AVG function to quickly calculate the average value of a particular column. The statement below returns the average number of downloads for an app in our database. So you can see select AVG downloads. The average function works by taking a column name as an argument and returns the average value for that column. Calculate the average number of downloads for all apps in the table. In the code editor below, do select, so AVG downloads. So that's going to be taking the average of all rows that have downloads filled in that are not null. That's one thing to note, the average won't use null values in calculating. Remove the previous query, write a new query that calculates the average price for all the apps in the table. So again, I'm just going to delete this and put in price. And the average price is about $2. By default, SQL tries to be as precise as possible without rounding. We can make the result table easier to read using the round function. Round takes two arguments inside the parentheses, a column name and an integer. It rounds the values in the column to the specified to the number of decimal places specified by the integer. So here you round the price to 0. So if it's $14.99, it'll round up to 15. Here you pass the column price and integer 0 as arguments. SQL rounds the values in the column to 0 decimal places in the output. Let's return the name column. All right. And a rounded price column. So we're going to do name and then round price, comma 0 from fake apps. End it with a semicolon. Run that. So you can see silicon phase is 0 when it's rounded. And you can see the other values as well. And now remove the previous query. In the last exercise, we were able to get the average price of an app of 2.02 using this query. Now let's edit this query so that it rounds the result to 2 decimal places. This is a tricky one. It's not too tricky, actually. So first we're going to do average price. So this would give you the average price. And then around that, we're going to put the round function. So this gives us the column that we're looking for, and then we're going to round that to 2 decimal places, and we're still taking from the fake apps table. And yep, 2.02 is the answer. Group by 1. Oftentimes we want to calculate an aggregate for data with certain characteristics. For instance, we might want to know the mean IMDb ratings for all movies each year. We can calculate each number by a series of queries with different where statements like so. So we got average rating, where the year equals that, or that, or that, and so on. Luckily, there's a better way. We can use group by. So here you've got a year, the average, and then you group by the year. So group by is a clause in SQL that is used with aggregate functions and is used in collaboration with the select statement to arrange identical data into groups. The group by statement comes after any where statements, but before order by or limit. All right, in the code editor, we're going to go select price, and we're going to count all the rows. And then we're going to group by the price. So what you're going to get is you're going to get each unique price is going to be in the table that's outputted, and it's going to count the number of rows that have that price. You can see the biggest group is the free, 0. And then in the previous query, add a where clause to count the total number of apps that have been downloaded more than 20,000 times at each price. All right, so we're just going to put in a where downloads greater than 20,000. It's running and it's finished, so you can see it cut down the numbers there. All right, remove the previous query, write a new query that calculates the total number of downloads for each category. Okay. So we're going to delete the where clause. So category, we're going to put that here. And then we have to group by it. And then we're going to use sum of downloads to get the sum of downloads, and we're going to call that total downloads. And we'll run that. And that's good. So you can see we use an alias here. It didn't tell us to do that, but it makes sense for a lot of your queries. If you're doing like a sum or an average function, it's easier to read if you have some sort of alias. All right, group by to. Sometimes we want to group by a calculation done on a column. For instance, we might want to know how many movies that have IMDb ratings that round to 1, 2, 3, 4, 5. We could do this using the following syntax. So you can see they rounded it, and then they're just counting how many have that. And then you group by that. So anything that's not an aggregate function, like count, sum, average, max, min, you should be putting in your group by basically. However, this query may be time consuming to write and more prone to error. SQL lets us use column references in our group by. That'll make our lives easier. 1 is the first column, 2 is the second column, 3 is the third column, and so on. The following query is equivalent to the one above. So here you can see they substitute a 1 instead of this round statement. Suppose we have the query below. Write the exact query but use column reference numbers instead of column names after group by. So we've got select category, we got price, we got average downloads, and I'm going to put this as average downloads. And we'll go from fake apps, and then group by 1, 2, and finish it with a semicolon. And there we go. So you can see the output. Got the category, the price as the different groups, and then it's averaging over those groups. Having. In addition to be able to group data using group by, SQL also allows you to filter which groups to include and which to exclude. For instance, imagine that we want to see how many movies of different genres were produced each year, but we only care about years and genres with at least 10 movies. We can't use where here because we don't want to filter the rows, we want to filter groups. This is where having comes in. Having is very similar to where. In fact, all types of where clauses you learned about thus far can be used with having. We can use the following for the problem. So you're selecting the year and the genre as the groups, and then you're doing a count of all the non-empty rows that with a name, and then you're looking at only the groups that have a count of name greater than 10. When we want to limit the results of a query based on values of an individual row, use where. When we want to limit the results of a query based on an aggregate property, use having. Having statements always come after group by, but before order by and limit. Suppose we have the query below. Okay. Select price, rounding the average downloads, and then counting each row in the group of price. It returns the average downloads rounded and the number of apps at each price point. However, certain price points don't have very many apps, so their average downloads are less meaningful. Add a having clause to restrict the query to price points that have more than 10 apps. Okay, I'm going to select this as my structure. So having comes after the group by. So we're going to put having count star, and what did they say, greater than 10? Having more than 10. Let's run that. And there we go. So these are the different price groups. Here's the rounded average downloads, and you can see the counts. All of them are greater than 10 because we put that having statement on there. All right, review. You just learned how to use aggregate functions to perform calculations on your data. What can we generalize so far? Count the number of rows, sum the sum of the values in a column, max, min, the largest, smallest, respectively. AVG, the average of the values in a column, round the values in the column. Aggregate functions combine multiple rows together to form a single value of more meaningful information. Group by is a clause used with aggregate functions to combine data from one or more columns. Having limit the results of a query based on a aggregate property. So having's like where, except it's for the result of a group, such as a count or an average or a sum or something like that. And that's it for this lesson in SQL. All right, so hope you guys are able to follow along. You can always pause the video and type things as you need to, but I hope you guys learned something, and I hope that you will come back for the next part. Thank you very much.